All right, so today's lesson is 221, which is titled Dilations. And the title is, what do these shapes have in common? So for question 46, it's the warm-up stretch using the rubber bands like we just did. Okay, so before computers and copy machines existed, it sometimes took hours to enlarge documents or to shrink text, place on small objects like jewelry. A pantograph device like the one shown below was often used to duplicate and enlarge written documents and artistic drawings. Okay, the picture they have right here is really hard to see, but it's this little tool that they used to enlarge it or shrink it. It says, what will the images look like? They'll look pretty much the same. They'll just either be larger or smaller. We made ours double or triple the size. What do the images have in common with the original? They have the same angles, but the sides are larger. Okay? What is different? That would be the sizes would be magnified or shrunk. And go ahead and turn to page 14. All right. At the top of page 14 is question 48, which is titled Similar Polygons. Is one of the sailboats different from the others? Are all four sailboats unique? Do any of the sailboats have something in common? Okay, so these sailboats are similar. You're going to use the word similar, but they are slightly larger or slightly smaller. We use the word similar to describe two polygons that look alike, but may be different sizes. More specifically, similar polygons can be mapped onto each other with a sequence of rigid transformations and a dilation. For each set of polygons below, 3 are similar. That is, they are related through a sequence of transformations, including dilation. And 1 is an exception. What is the exception in each set of polygons? You can use tracing paper if you want, but we're going to be able to see it in just a second. I lost my place. Sorry. Use tracing papers to help answer each of these questions for both sets of shapes below. Which polygons appear to be the exception? What makes that polygon different from the others? What do the other 3 polygons have in common? What sequence of transformations would map one polygon onto another? So for part A and B, down at the bottom, okay? If you look at part A, you have A, B, C, and D right here. Which one is not similar? That would be D is not similar. See how it's kind of slanted? That means it's not going to have congruent angles. Okay? But A, B, and C will be translations of each other and what we call dilations, or you dilate them. You make them bigger or you make them smaller. Okay? And for part B, G is the one that is not similar. You're going to notice that this angle is bigger, and so G does not fit in with that group. But E, F, and H are just translations. One of them is even a reflection, but they all have a slight dilation, either bigger or smaller. Okay? If you can't see it, you can use some tracing paper and figure that one out. All right? All right. Raise your hand if you're still writing. A couple people? Okay. All right. So for question 47, you're going to work in groups of 4. And when I divide you up into groups, I'm going to give you 2 things. I'm going to give you a piece of paper that is in one of these plastic sleeves and one of these vis-a-vis markers. And you're going to be stretching a figure as you did in question 4. Well, we did with the rubber bands, okay? And let's see. Okay, so for part A, it says, imagine that a rubber band chain is stretched from the origin so that the first knot traces the perimeter of the original polygon. We're going to dilate the polygon from the origin by imagining a chain of 2 or 3. Cross off 4 and 5. We're not going to do 4 and 5. We're just going to do 2 and 3 rubber bands to form A prime, B prime, C prime, D prime. Each member should pick a different number of rubber bands. That's okay. For example, if your job is to stretch A, B, C, D with 3 bands, A prime should be located as shown in the diagram below. Okay. So for the first one, you're going to take this quadrilateral right here, and you're going to use the center of this one as the point of dilation. So to get from there to this corner labeled A, you go up 2 and then over 3. So to dilate it 2 times, you would go up 2 and over 3 and put a point right there. Okay? So here's what it's going to look like when you do it on the little paper I give you. This is going to allow you to mess up in case you need to mess up. This can be erased. Okay? So if this is the center where they want you to dilate from, you would count up 2 over 1, 2, 3. Bless you. Up 2 over 1, 2, 3. And you would call that A prime. You would do the same for B. You go up 2, backwards 1. So from B, you go up 2, backwards 1. And that would become your B prime. To get to C, you would go backwards 2, down 2. So you go backwards 2, down 2. And that would become your C prime. To get from the center to D, you go 1 to the right and down 2. So you go down 1 to the right and down 2. And that becomes your D prime. Then you connect all those points and watch what happens. What did I just do to the original shape? I doubled it, right? So that's the doubling of the original shape. The angles are all the same, but the sides are going to be twice the length. Okay? And then that's a double. So now I'm going to triple it. So from here, you went up 2 over 3, you go up 2 over 1, 2, 3, and you do it again. And you do that from here to here. You do it all the way around until you triple the shape. Once you are satisfied and everybody in your group agrees, yes, that's correct, then you're all going to draw it on your paper in this box. Okay? Then you're going to flip over to page 13 and you're going to do the same thing with the triangle. So you're going to double it and then you're going to triple it. This time the point of dilation is outside the triangle. So to get from here to F, you go 2 to the right and up 2. So you go 2 to the right and up 2. That becomes your F prime. To get to G, you go 10 to the right. So you're going to go another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's going to be your G prime and so on. So you'll double it and then you're going to triple it. When your whole group is satisfied with it, you're going to copy it onto here. Okay? Does that make sense? All right, awesome. So you're going to send, So you're going to send one person